Welcome back to another show. All these days I was doing PYQs of JEE Main, KCT series from 1984 to 2025 chapter wise, NDA paper I have done, NCRT I have done. This time I'm starting concept videos for JEE Main. The topic is Parabola, one I call. In this video, I'll be discussing one of the most important concepts of the parabola. Okay, the parametric relationship between the endpoints of the focal chord and the length of the focal chord, all those things, and also work out a few problems based on that. Okay, so quite important concept for JEE Main. Frequently, questions are asked from this section. Okay. So I'll explain the parabola with the parametric equations and focal chord. That means mainly I'm discussing about the focal chord, the length of the focal chord and the parametric relationship between the endpoints of the focal chord. First we will see what is the focal chord. Okay. We will take the standard form of the equation of the parabola. Y square is equal to 4ax. Okay. Y square is equal to 4ax will take the parabola in the standard form. The parabola in the standard form, y square is equal to 4ax, having the focus at a comma 0, we know. X-axis, origin, y-axis. The parabola y square is equal to 4ax, look at this. The parabola y square is equal to 4ax. This is directrix. The directrix is x is equal to minus a, we know. The equation of the directrix. And the focus is a comma 0. The chord which passes through the focus is called as the focal chord. S is a comma 0, we'll call this point as S. S is a comma 0. Any chord which passes through the focus is called as the focal chord. You must know this. The basic definition of the focal chord. I can draw many focal chords. This is one focal chord. This is another focal chord. And the lattice rectum is a focal chord which is parallel to directrix. Okay. Also, I'll discuss a little bit of lattice rectum also. Few things about lattice rectum connecting with the focal chord. Okay. So focal chord means the chord which passes through the focus. You must know this. Focal chord. What is the definition of the focal chord? Focal chord is the chord which passes through the focus. Is the chord which passes through the focus. The chord which passes through the focus. The chord which passes through the focus is called as the focal chord. Okay. So there are two endpoints of a focal chord, correct? We can get the relationship, the parametric relationship. And for the parabola, y square is equal to 4ax. This is the basic definition of the parabola. Basic definition of the focal chord of the parabola. For y square is equal to 4ax, the parametric equations are, and this parabola is called the right-handed parabola. Of course, A is positive taken. The parametric equations are, x is equal to at square, comma y is equal to 2at. These are the parametric equations of the parabola. So there are two ends for a focal chord. Okay, I'll get the parametric relationship between the endpoints of the focal chord. Suppose the endpoint of the focal chord A is taken as at1 square comma 2at1, at1 square comma 2at1, and the other end point of the focal chord B is going to be, I'll take in the form of at2 square comma 2at2. Okay. A is in terms of t1 and B is in terms of t2. The relationship between the endpoints of the focal chord is that t1 into t2 is equal to minus 1. Okay. This is a relationship between the endpoints of the focal chord. That means to say that if you know the one end of the focal chord, we can write the coordinates of the other end of the focal chord using this relationship. Okay, T1 into T2 equal to -1. So I shall derive this. Okay, I'll derive this and also I'll deduce the length of the focal chord in terms of the parameter T, and also I can deduce the length of the focal chord in terms of the angle alpha, where the focal chord is making an angle alpha with positive x-axis, because questions are asked from this section repeatedly in JEE main exams. Okay, so now first I'll derive that T1 T2 equal to -1. If you know the endpoints of the focal chord as the in terms of the parameter T1 and T2, the endpoints, we have this condition T1 into T2 equal to -1. Okay, so I'll write the first point, the first result I'm going to do here is the parametric relationship between the endpoints of the focal chord. The parametric relationship. The parametric relationship. Parametric relationship between the endpoints of the focal chord. Between the endpoints of a focal chord. Parametric relationship between the endpoints of a focal chord. Okay, so I shall draw the parabola y square is equal to 4ax and take endpoints in terms of the parameter T1 and T2. Okay, the proof I can write the proof for this. Take a parabola, y square is equal to 4x, and this is the directrix, x is equal to -a, the equation of the directrix, this is origin. We have the parabola, y square is equal to 4ax, x-axis, origin, y-axis, and the focus is S, which is a comma 0. Any chord which passes through the focus is called as the focal chord, and this is a T1 square comma 2a T1. The other end of the focal chord is B, which is a into T2 square comma 2a T2. One end of the focal chord is AT1 square comma 2AT1. Other end of the focal chord is AT2 square comma 2AT2. Okay, and this is S. The focus is S, A comma 0. It is overlapping with the focal chord. I will represent it properly here. The focus is S. This is A and this is S, A comma 0. This point is A, S, B. Okay, S is the focus and this is the focal chord. If you want, you can draw the focal chord little bit slant so that it is not coinciding with the lattice rectum. Even lattice rectum is a focal chord only. Okay, need not worry about that. This is S, A comma 0. Okay, AB is the focal chord. Focal chord is a chord which passes through the focus. Focus is A comma 0. I want to deduce that T1 into T2 equal to -1. The relationship is T1 into T2 equal to -1. I am going to deduce this. To prove this, T1 into T2 equal to -1, I will use the condition that the 3 points are collinear. Clearly the points A, S and B are collinear, that lie on the same line. Clearly the points the points A, S and B are collinear. The points A, S and B are collinear. A, S and B are collinear. So if 3 points are collinear, we can use the condition that slope of AS equal to slope of SB. 3 points lie on the same line means for a given line slope is constant. So I'll use the concept that slope of AS is equal to slope of SB or slope of BS, whatever. Slope of AS is what? How to find slope of line joining 2 points? Y2 minus y1 by x2 minus x1. Correct? Slope of AS is 0 minus 2at1. 0 minus 2at1 divided by a minus at1 square. Slope of SB. Slope of SB is y2 minus y1 by x2 minus x1. 2at2 minus 0. 2at2 minus 0 divided by at2 square minus a. From this, what I get? Minus 2at1 divided by, here a is common, what remains is 1 minus t1 square is equal to 2at2 divided by a into t2 square minus 1. Correct? 2a cancels. 2a is going to cancel. Here a is going to cancel. So what is left is here minus t1 into t2 square minus 1 on cross multiplying. Here what is left is t2. This you take it to right hand side numerator, 1 minus t1 square. Multiply this, open the bracket, minus t1 into t2 square plus t1 is equal to t2 minus t2 into t1 square. Rearrange the terms. From this term I'll take it to the left hand side so that I can take t1, t2 common. If you take t1 into t2 common, this is taken to the left hand side, it becomes plus t1, t2 is out, what remains is t1 minus t2. Here t2 minus t1. T1 is not equal to T2, so I can cancel T1 minus T2 from left hand side and right hand side. If you cancel these two, I get minus 1. Correct? Therefore, from this, I can write T1 into T2 is equal to minus 1. As T1 is not equal to T2, I can cancel it. T1 is not equal to T2. T1 minus T2 not equal to 0. I can cancel these two. If I cancel these two, I get minus 1. T1 minus T2 is minus of T2 minus T1. So this and this, if we cancel, I get minus 1. So this is the parametric relationship between the endpoints of the focal chord. In other words, if you know one end of the focal chord as 80 square comma 280, the other end of the focal chord can be got by replacing T by minus 1 by T. Okay, so you can note that if one end of the focal chord, one end of the focal chord is focal chord AB, one end of the focal chord AB is A 80 square comma 280, then the other end of the focal chord is got by replacing T by minus 1 by T. So if you replace T by minus 1 by T, A into minus 1 by T the whole square, that is A by T square. And replace T by minus 1 by T, this becomes minus 2A divided by T. How to get? If you know one end of the focal chord as 80 square comma 280, other end of the focal chord is got by replacing T by minus 1 by t. Remember this. Replacing t by minus 1 by t. Okay. This is the point to be noted. So learn this as endpoints of the focal chord. The two endpoints of the focal chord in terms of the parameter t. A can be got from the equation of the parabola. Y square is equal to 4x. From there we get the value of A. Correct? So this is the first derivation. Okay? The parametric relationship between the endpoints of the focal chord. Next I am going to derive the length of the focal chord in terms of the parameter t. Okay? The second result I am going to do is the length of the focal chord. The length of the focal chord. Length of the focal chord. Length of the focal chord of the parabola y square is equal to 4ax of the parabola y square is equal to 4ax is a into t plus 1 by t the whole square. Length of the focal chord is this, a into t plus 1 by t the whole square. We know if one end of the focal chord is at square comma 2at, other end is a by t square comma minus 2a by t. If you apply the distance formula between these 2 points, I can find out. That is one method. Another method is I can use the segments of the focal chord. Okay. So to prove this, I'll use the segments of the focal chord. Proof. We have the parabola y square is equal to 4x. This is the parabola. This is the focus. Yes, a comma 0. Yes, is a comma 0. And this is the focal chord we have. This is at square comma 2at. Okay. I'll name it as SP and SQ as the segments. Okay. PQ be the focal chord. SP and SQ are the segments of the focal chord. This will call it as P, y-axis, origin, and this is the directrix, which is whose equation is x is equal to minus a. This is PQ. PQ is the focal chord. P is at square comma 2at. Q is going to be a by t square. A by t square comma minus 2a by t. Okay. So length of the focal chord is PQ. We have length of the focal chord is PQ. Length of the focal chord is equal to PQ. PQ is equal to PS plus SQ. Correct? You can split this as PS plus SQ. From the definition of the parabola, PS is same as PM. Okay. This is the directrix. And SQ is same as QN. Okay. It follows from the definition of parabola that the point P moves as that distance from the fixed point is equal to distance from the fixed line. Okay, SP is equal to PM. My figure is a rough. Okay, it's not very accurate, not a very exact figure. From the figure I can see that they are not equal. SP is equal to PM. I should draw the direction little bit this side. Okay, figure is very rough only for understanding purpose. It follows from the definition of the parabola that PS is same as PM. So I'll replace PS by PM. I'll replace SQ by QN. Okay. By definition it follows. And PM is nothing but this much plus this much. Correct? So we know in the parabola focus is a comma 0. This much is a. Even this much is a. Okay. This is same as this. So this is a and this is at square because x coordinate is at square. No, this much is at square. At square plus a I can write. PM is at square plus a. Okay. So PM I will replace it by at square plus a. Pm is how much? A plus at square. This is Pm. What about Qn? Qn is this much is A and this much is A by T square, correct? This length is A by T square. This length is A. So A plus A by T square is Qn. A plus A by T square. You see that A is present everywhere. A is common. I can take outside. So what remains is 1 plus T square plus 1 plus 1 by T square is equal to A into what we have, T square plus 1 by T square plus 2. 2 is 2 into T into 1 by T, correct? So I can complete the square. This is T plus 1 by T the whole square. Learn this as a formula. Okay. Length of the focal chord, I can call it as L is equal to A into T plus 1 by T the whole square. Or I can take it in the form of L is equal to A into T1 minus T2 the whole square. Because parameter T is T1 and 1 by T is minus T2. Because T2 is minus 1 by T. Also I can write in the form of A into T1 minus T2 the whole square. Same as A into T2 minus T1 the whole square. Okay. So learn this as a formula. Length of the focal chord can also be written as note the length of the focal chord, length of the focal chord can also be written in the form of A into T1 minus T2 the whole square, where T1 and T2 are the parameters of the endpoints. T1 is the point A and T2 is point B, or this is A into T2 minus T1 the whole square. Okay. T1 and T2 are the parameters. Okay. This also I can write. Another I am going to derive is the length of the focal chord in terms of the angle alpha. Okay. The third result we have the length of the focal chord. The length of the focal chord is L is equal to 4a cosecant square alpha. 4a cosecant square alpha, where alpha is angle made by the focal chord with the positive x-axis, where alpha is angle made by the focal chord. Alpha is the angle made by the focal chord. Angle made by the focal chord with positive x-axis. With positive x-axis. Length of the focal chord. So we'll draw the parabola. The focal chord is passing through the focus. It makes an angle alpha with positive x-axis. S is the focus, A comma 0, and the directrix is here. X is equal to minus A. P is one end of the focal chord. Q is other end of the focal chord. The focal chord PQ makes an angle alpha with a positive direction of x-axis. Then the length of the focal chord is 4a cosecant square alpha. Okay. Already we have the length of the focal chord as a into t plus 1 by t the whole square from this. Correct? A into t plus 1 by t the whole square. I'll express this in terms of slope now. Okay. So we'll find the slope of PQ now. P is what? 80 square comma 280. Once again I'm writing this. Slope of PQ I want to find out. So I'll write the coordinates of P in terms of the parameter T, 80 square comma 280. Slope and coordinates of the point Q is going to be A by T square comma minus 2A by T. A by T square comma minus 2A by T. So slope of PQ I'll find out. Slope of PQ. Slope of PQ is how much? PQ is making an angle alpha with positive x-axis. Slope I can write it as tan alpha. Correct? Tan alpha is also equal to, I can find the slope in terms of the formula y2 minus y1 by x2 minus x1. Difference in y by difference in x. Correct? Take the difference in y coordinates divided by difference in x coordinates. Minus 2a by t minus 2a divided by t minus 2at divided by, subtract the y coordinates divided by, subtract the x coordinates, a by t square minus at square, a by t square minus at square. So what do you get? Tan alpha is equal to, from this, I'll take minus 2a common in the numerator, minus 2a is common, so what remains is 1 by t plus t. In the denominator, we can take a common, so what remains is 1 by t square minus t square. A is going to cancel, and I can factorize this, a square minus b square form, a plus b into a minus b. So what I am going to get is minus 2 into t plus 1 by t divided by, this is 1 by t minus t, 1 by t minus t into 1 by t plus t. So 1 by t plus t is going to cancel. So what is left is minus 2 by 1 by t minus t, or minus I'll absorb for denominator and write this as 2 by t minus 1 by t. So this is tan alpha. Okay, tan alpha we got it as 2 by t minus 1 by t. So t minus 1 by t is 2 by tan alpha. From this I can tell. What I can tell from this, t minus 1 by t, from this t minus 1 by t is equal to 2 by tan alpha, or I can write this as 2 into cot alpha. Okay, and we have the length of the focal chord as a into t plus 1 by t the whole square. Correct? So using that I can simplify and get the answer. Okay, length of the focal chord, I'll write here itself. We have length of the focal chord L is equal to a into t plus 1 by t the whole square. Correct? Is equal to a into, we know the basic algebraic identity, a plus b the whole square is a minus b the whole square plus 4ab. Correct? Using this formula, a plus b the whole square, a plus b the whole square is equal to a minus b the whole square plus 4ab, the basic algebraic identity, using this formula. So t plus 1 by t the whole square is t minus 1 by t the whole square plus 4 into t into 1 by t. T minus 1 by t the whole square plus 4 into t into 1 by t. T cancels. Correct? So what I am going to get here is length of the focal chord is equal to a into, what is t minus 1 by t, we got 2 cot alpha. Correct? 2 cot alpha the whole square is 4 cot square alpha. 4 cot square alpha plus 4. Correct? T got cancelled, 4. 4 is common, so 4 comes outside. What remains inside the bracket is 1 plus cot square alpha, which is cosecant square alpha. So finally I'll write here t minus 1 by t. Finally I'll write here the answer. Therefore the length of the focal chord is 4 is common, 4 comes outside. So 4a into 1 plus cot square alpha. This is 4a into 1 plus cot square alpha is cosecant square alpha. Hence finally proved. Okay. So the important things, once again I am recalling, if you know one end of the focal chord of the parabola y square is equal to 4x as at square comma 2at, other end is got by replacing t by minus 1 by t, which is a by t square comma minus 2a by t. Length of the focal chord of the parabola in terms of the parameter t is a into t plus 1 by t the whole square. and length of the focal chord in terms of the angle alpha, where the focal chord is making angle alpha with positive x-axis, is given by L is equal to 4a cosecant square alpha. All these three I have derived it. Okay, I got the slope as tan alpha 2 by t minus 1 by t. So tan alpha is 2 by t minus 1 by t, means t minus 1 by t is 2 by tan alpha, which is 2 cot alpha. I wrote here. Okay, t minus 1 by t is 2 cot alpha. Using this length of the focal chord, we know a into t plus 1 by t the whole square, which is a into a plus b whole square formula, a minus b whole square plus 4ab. Using this formula I got. And here t cancels, only 4 remains. T minus 1 by t is 2 cot alpha. 2 cot alpha, the whole square is 4 cot square alpha plus 4. 4 is common. 4a into 1 plus cot square alpha. 1 plus cot square alpha is cosecant square alpha. So 4a cosecant square alpha. One more thing, just remember the segments of the focal chord, SP and SQ. Okay, the segments of the focal chord is a plus at square and a plus a by t square. Even that is required to work out the problems. Questions are asked based on that, even in 2025 JME. Okay, so one more thing I'm going to prove is the harmonic mean. Harmonic mean of the segments of the focal chord is the semilattice rectum. Okay, finally I'm going to prove this, the fourth one. The harmonic mean of the segments of the focal chord. Harmonic mean of the segments of the focal chord. Harmonic mean of the segments of the focal chord of the parabola. Y square is equal to 4ax of the parabola. Y square is equal to 4ax I'm discussing. Okay, is the semi-lattice rectum, is the length of semi-lattice rectum. Okay, proof. The segments of the focal chord are SP and SQ are called as the segments of the focal chord. SP is one segment, which is a plus at square, and SQ is other segment of the focal chord, which is a plus a by t square. Segments of the focal chord. I'll find the harmonic mean of this. Harmonic mean of the segments. What is harmonic mean of this? Harmonic mean of this, I'll call this the segment as L1 and this is L2. Harmonic mean of two numbers a and b is 2ab by a plus b, correct? So harmonic mean of two numbers a and b is in general given by 2ab divided by a plus b. Or I can write this as 2 divided by 1 by a plus 1 by b. So divide numerator denominator by ab, I'll get like this. So harmonic mean of L1 and L2 is 2 divided by 1 by L1 plus 1 by L2, which is 2 divided by 1 by L1. L1 is here, a plus at square. 1 by L1 is 1 by L1 will be 1 by a plus at square, correct? 1 by, I can take a common there, a into 1 plus t square is 1 by L1. And L2 is what actually? L2 I can write it as, if you take a common there, 1 plus 1 by t square, correct? Which is a into t square plus 1 divided by t square, L2. 1 by L2. 1 by L2 will be what? T square divided by a into 1 plus t square, reciprocal of this. T square divided by a into 1 plus t square. Now, this is 2 divided by, here a into 1 plus t square is common denominator. Correct? What it means is 1 plus t square. 1 plus t square will cancel. This a goes up. Correct? 2 divided by 1 by a, which is 2a. 2a is half of the length of the lattice rectum, which is the semi-lattice rectum. Correct? Hence I proved half of the length of the lattice rectum, which is length of the semi-lattice rectum. Half of the length of the lattice rectum is nothing but the length of the semi-lattice rectum. So harmonic mean of the segments of the focal chord is going to be equal to this. And also I can prove that the lattice rectum is the smallest focal chord. Okay, we have the length of the focal chord in terms of the parameter t as a into t plus 1 by t the whole square. If I expand it and use AMGM inequality, I can prove that the minimum length of that focal chord is 4a, which is the length of the lattice rectum. In other words, the lattice rectum is the shortest focal chord. Okay. So all these things we proved. The length of the focal chord in terms of angle alpha, in terms of the parameter t, here the parametric relationship between the endpoints of the focal chord, all these things I proved, correct? So in short, I'll add one more page here. So, and finally I can prove that the focal chord, the shortest focal chord is the lattice rectum. The shortest focal chord is the lattice rectum of the parabola. Shortest focal chord is the lattice rectum. We have the proof. We have the length of the focal chord as a into t plus 1 by t the whole square. We have the length of the focal chord as a into t plus 1 by t the whole square. Correct? So a into, expand this, t square plus 1 by t square plus 2 into t into 1 by t, of which t cancels. I am getting a into t square plus 1 by t square plus 2. We have AMGM inequality. Arithmetic mean is always greater than or equal to geometric mean. That is a plus b by 2 is always greater than or equal to root of ab. Take the first number a as t square and the second number b as 1 by t square. I want to use AMGM inequality and find the minimum value of this, t square plus 1 by t square. So t square plus 1 by t square, taking a as a t square and b as 1 by t square, greater than or equal to root of t square into 1 by t square. T square is going to cancel for t not equal to 0. Root 1 is 1, cross multiply this. So what I am going to get is t square plus 1 by t square is greater than or equal to 2. So this expression is greater than or equal to a into t square plus 1 by t square is greater than or equal to 2. So 2 plus 2, which is equal to 4. So this becomes 4a. So length of the focal chord is greater than or equal to 4a. Assume that a is positive here, so that 4a represents the length of the lattice rectum. Greater than or equal to means equality gives the minimum value. So minimum length of the focal chord is the lattice rectum, length of the lattice rectum. The shortest focal chord is lattice rectum. So minimum length of the focal chord I can tell. The minimum length of the focal chord, is the length of the lattice rectum, So all these things we have derived. Now we shall take the problems based on this. Once again I repeat, the parametric relationship between the endpoints of the focal chord. If one end of the focal chord is at square comma 2at, other end of the focal chord is a by t square comma minus 2a by t. Length of the focal chord in terms of the parameter t is a into t plus 1 by t the whole square. Or in terms of the parameter t1 and t2 you want, it is given by a into t2 minus t1 the whole square. And if you want to express the length of the focal chord in terms of the angle alpha where the focal chord is making with positive x-axis is given by L is equal to 4a cosecant square alpha. And the segments of the focal chord are given by SP and SQ. They are called as segments of the focal chord. SP is a plus at square and SQ is a plus a by t square. They are called segments of the focal chord. And the harmonic mean of the segments of the focal chord of the parabola is going to be the semi-lattice rectum, length of the semi-lattice rectum. Okay, so all these things I have done. in this section, and the shortest focal chord is going to be the latest rectum. So much we have discussed about the focal chord and the length of the focal chord and the parametric relationship between the endpoints of the focal chord. Now we shall take the problems, okay, which has appeared in the JEE main exams. The first one, we have one end of the focal chord of the parabola y square is equal to 16x is at 1,4. Find the length of this focal chord. Okay, so I need to find the length of this focal chord. I shall find out the length of the focal chord. From the parabola, y square is equal to 16x. Y square is equal to 16x. Compare with y square is equal to 4x. Comparing with y square is equal to 4x. 4a is equal to 16. So a is equal to 4. A is equal to 4 I got. So one end is already given, 1,4. Correct? One end is given. One end is given as 1,4. One end you compare with 80 square, 280. 80 square, 280. A is 4, no? A value we got it as 4. Substitute the value of A, 4 here. So 4t square, 2 into 4 is 8, 8t. Comparing this, 8t is 4 and 4t square is 1. Comparing this, we get 4t square is equal to 1 and 8t is equal to 4. This gives t square is 1 by 4, t is plus or minus 1 by 2. And this gives t is equal to 4 by 8, 1 by 2. So common value of t is 1 by 2. Correct? So take t as 1 by 2 and write the other end of the focal chord. One end is 80 square, 280. Other end is a by t square, minus 2a by t. So other end of the focal chord. Other end of the focal chord. The other end of the focal chord is. Other end of the focal chord is a by t square, minus 2a divided by t, which is, substitute the values. A is 4, a is 4 and t is half square is 1 by 4. Minus 2a, a is 4, 2 into 4 is 8, minus 8 divided by t is half. So this becomes 4 into 4, 16. Here 2 goes up, gets multiplied to 8, so it becomes minus 16. So one end is given in the question already, 1,4. Other end we got 16, minus 16. The figure looks like this. The figure looks like this. One end of the focal chord is given as 1,4 and other end of the focal chord is here. It lies in the fourth quadrant. The first one end is lying in the first quadrant, A I'll call, which is 1,4, which is given in the question. And the other end is this, B, which is 16, minus 16. Okay. So figure looks like this. If you find the distance between these 2 points, we get the length of this focal chord. Therefore, length of the focal chord is AB, I'll call. AB, which is root of applying distance formula. The other end of the focal chord is B, I'll call. This is B and this is A. Okay, so find out AB by using distance formula. 16 minus 1 the whole square, root of 16 minus 1 the whole square, plus minus 16 minus 4 the whole square, minus 16 minus 4 the whole square. 16 minus 1 is 15, 15 square is 225, and this is minus 20 square, which is 400, which is root of 625. Root of 625 is equal to 25. So answer is option D. Option D is answer. Please make a note. Move on to the next one. Question number 2 we have. One end of the focal chord AB of the parabola y square is equal to 8x is given, half comma minus 2. Find the equation of the tangent to it at the B. So other end of the focal chord I have to find out. So y square is equal to 8x. Y square is equal to 8x, the parabola. Of course, there is a directrix here. This is y square is equal to 8x. Compare with y square is equal to 4ax. We get 4a is equal to 8. So a is equal to 2. A is equal to 2. One end is given as half comma minus 2. You have to find the other end. Half comma minus 2 lies in the fourth quadrant. Half comma minus 2. Okay. Find the other end of the focal chord. This is 80 square comma 280 you take. 80 square comma 280. A already we know. A is 2. Correct. 2t square comma 2 into 2 which is 4t. So compare. 2t square is equal to half. Comparing this we get 2t square is equal to half and 4t is equal to minus 2. So t square is 1 by 4. T square is 1 by 4 and t is minus half. So here we get t is plus or minus half. So common value of t is minus half. So I'll take the parameter t as minus half. Okay, t is minus half. Put t equal to minus half to find the other end of the focal chord. The other end of the focal chord is B. The other end of the focal chord. Other end of the focal chord is B, which is a by t square comma minus 2a by t. Correct? Which is B. A how much? A is 2, t is minus half. A is 2, t is minus half. Minus half square is 1 by 4. Minus 2a. A is 2, so minus 2 into 2 becomes minus 4 and t is minus half. T is minus half. That is, this 4 will go up, becomes 4 2s are 8. This 2 goes up, minus minus will cancel, 8 comma 8. So something like this. The focal chord is something like this. Point B is 8 comma 8. To find the tangent at this point, to find the equation of tangent at the point B. Okay. How to find the equation of tangent we know. Replace y square by y1, x by x plus x1 by 2. Y square is equal to 8x is given. The parabola is y square is equal to 8x. The tangent to this parabola, I'll call it as a t. Y square becomes y1. X becomes x plus x1 divided by 2. So what you get is y into y1 is equal to 4 into x plus x1. Correct? Tangent is drawn at the point B. We want to find the equation of tangent at the point B. B is 8 comma 8. Correct? At that point, put x1 as 8, y1 as 8. y1 as 8. 8y is equal to 4 into x plus x1 is 8. 4 1s are 4 2s are. So 2y is equal to x plus 8 or x minus 2y plus 8 equal to 0. X minus 2y plus 8 is equal to 0. Equation of tangent is this. X minus 2y plus 8 equal to 0. This option C. Please make a note. One end of the focal chord is given. Find the other end of the focal chord. Then write the equation of tangent at the point B. Tangent is got by replacing y square by y1. X becomes x plus x1 by 2. Please make a note. Move on to the next one. Question number 3 we have. The question asked in the year 2024 JEE Main, 4th of April, first shift. The length of the focal chord PQ of the parabola is given as 15 units. Want to find the distance of PQ from the origin. So parabola is there. Y square is equal to 12x. Y square is equal to 12x. The parabola. Okay. Origin. Y square is equal to 12x. can compare this with y square is equal to 4ax. So 4a is equal to 12, a is equal to 3. A is equal to 3. The directrix is here. Okay, we are not worried about this. X is equal to minus x equal to minus 3 I can write. And length of the focal chord is given as 15 units. Okay, length of the focal chord is given as 15. So this length is 15. This is 3 comma 0. The focus. And length of this focal chord PQ is given as 15 units. Length of the focal chord, we know, I'll use the formula 4a cosecant square alpha. Length of the focal chord is 4a cosecant square alpha. Length of the focal chord is given to be equal to 15. So 15 is equal to 4 into a value is 3 from this parabola. From the parabola I got the value of a as 3. So cosecant square alpha, I'm going to get this as 15 by 12, or 3 ones are 3 5s are cancels. So cosecant square alpha is equal to 5 by 4, or cosecant alpha is root 5 by 2. Okay, plus or minus, we'll take the positive value of course. Now this is the angle alpha actually. This is the angle alpha. The focal chord is making an angle alpha with positive x-axis. Then length of the focal chord is 4a cosecant square alpha, that we know. So they asked to find the distance of PQ from the origin. Is P, want to find 10p square. So PQ is the focal chord. You have to find the distance of this PQ from the origin. Distance means the perpendicular distance. So draw one perpendicular like this. Okay, this length is given to be equal to P, small p this is. Okay, I have to find out P first. To find out P, what I'll use, this angle is alpha, no? So even this angle becomes alpha. This angle is also alpha. Okay, so in this small triangle OSM I'll call. In triangle OSM, I can define cosec alpha. Okay, in triangle OSM, what is cosec alpha? Cosec alpha is hypotenuse divided by opposite side. This angle is 90, side opposite to 90 is hypotenuse. In triangle OSM, cosec alpha is going to be cosec alpha is hypotenuse by opposite side. Opposite side is OM, correct? And OS is hypotenuse. So cosec alpha is equal to hypotenuse, which is OS, divided by opposite side, which is OM. OS how much? OS is 3. OS is 3 and OM. OM is P from the figure, correct? So cosec alpha is 3 by P. So cosecant square alpha is going to be how much? Square this and that. Cosec alpha is 3 by P. OS is 3, correct? And OM is P. Hypotenuse divided by opposite side. Hypotenuse is OS and opposite side is OM, which is P. So cosec alpha is 3 by P. Cosecant square alpha is 9 by P square. Squaring this and writing here, correct? Cross multiply this, will get P square, or 5p square is equal to 36. From this 10p square, multiply by 2. Multiply by 2. 10p square is going to be multiply by 2 on both sides. That becomes 72. Required answer is 72. Please make a note. I used the length of the focal chord in terms of angle alpha so that we get the answer easily. Move on to the next one. Suppose AB is a focal chord of this parabola. Y square is equal to 12x of length L and slope m less than root 3. Distance of the chord AB from the origin is D. Find LD square. Numerical type question asked on 5th of April 1st shift JM 2024. Again, I'll represent the parabola. Y square is equal to 12x. Y square is equal to 12x. Compare this with the equation of the parabola in the standard form. Y square is equal to 4ax. 4a is equal to 12. So a is equal to 3. The value of a is 3 here. Okay. And they told AB is the focal chord. 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 Okay. The distance of the chord AB from the origin is D. Distance of the chord AB from the origin is D. Of course, there is a directrix here. X equal to minus 3 here, the directrix. This is the perpendicular drawn. The distance of the chord AB from the origin is D. So I'll call this as M here. OM is D. Okay. OM is equal to D. And this is S, the focus, which is 3 comma 0, because focus is A comma 0, A is 3. So, and this angle is alpha, as I told earlier. I'll represent alpha here. There is no space if I represent like this. This angle is alpha. This angle is alpha. Even this angle is alpha. S is the focus, which is 3 comma 0. So OS is 3. OS is going to be equal to 3. And they told want to find LD square. Okay. Focal chord is of length L. Focal chord is of length L. Okay. We have L is equal to 4a cosecant square alpha. Once again, using the same result. L is equal to 4a cosecant square alpha. 4 into a is 3. Okay. Length of the focal chord is L. Is given by 4a cosecant square alpha. From the parabola a is 3. Cosec alpha I'll find out. In this triangle OSM. In triangle OSM. Same as the earlier question. Almost same. Cosec alpha is how much? Cosec alpha is equal to. Cosec alpha is opposite side, hypotenuse divided by opposite side. Hypotenuse is opposite to OM, opposite to 90, which is OS. OS divided by OM, correct? Cosec alpha, hypotenuse divided by opposite side. Opposite to 90 is OS, that is hypotenuse. OS is hypotenuse and OM is opposite side. OS is 3 and OM is D. Correct? Use this. So what we have? Cosec alpha is 3 by D. Correct? Cosec alpha is 3 by D. Substitute 3 by D the whole square. Want to find LD square. 4 into 3 square is 9 divided by D square. So this is cross multiplied. Therefore LD square is equal to 4 into 3 is 12. 12 into 9 is 108. They asked to find LD square, which is 108. Quite simple question. Okay. So two questions that are asked based on the length of the focal chord as 4a cosecant square alpha. Please make a note. Move on to the next one. Question number 5. This is given like this. P, the point P of the focal chord PQ of the parabola P1 comma minus 4. Parabola is this. Y square is equal to 16x. The focus of the parabola divides the chord PQ in the ratio m is to n. GCD of m comma n is 1. Want to find m square plus n square. Okay. Question asked on 2nd of April, second shift, 2025 JEE main. Okay. So y square is equal to 16x is the parabola here. Y square is equal to 16x. Y square is equal to 16x. Compare with y square is equal to 4ax. 4a is equal to 16. So a is equal to 4. From the parabola, a is equal to 4. Correct? A is equal to 4. So point P of the focal chord. PQ is the focal chord and the point P is given 1 comma minus 4. Point P lies in the fourth quadrant, 1 comma minus 4. One end of the focal chord is given. Okay. And the focus of the parabola I can write. Focus is a comma 0. Correct. Focus is a comma 0, which is 4 comma 0. I can find the coordinates of the point Q. Okay. PQ is the focal chord. Focal chord always passes through the focus. One end is given. We can find the other end. We compare this one end with 80 square comma 280. 80 square comma 280. A is already 4, correct? This is 40 square comma 80. 40 square comma 80. 40 square is 1. Compare. 40 square is equal to 1 and 8t is equal to minus 4. T square is 1 by 4. This is T is equal to minus half. Here I get T is plus or minus half. I'll take the common value of T as minus half. The common value of T is minus half. T is minus half. So other end of the focal chord will be A by T square comma minus 2A by T. Correct? The other end of the focal chord I'll call Q, which is A by T square comma minus 2A divided by T, which is, that is, Q is A is 4 and T is minus half. Minus half square is 1 by 4. 2A. A is 4, 2A is 8. So minus 8 divided by T is how much? Minus half. T is minus half. That is, Q is 16 comma minus minus cancels. 8 2s are 16. Correct? So Q is 16 comma 16. Q is 16 comma 16. So other end of the focal chord we got. Now I have to find out in what ratio the focus of the parabola, focus is yes, it is in what ratio the focus of the parabola divides the chord PQ. I have to find out, that is M is to N. Okay, so let it divide in the ratio lambda is to 1. Let S divide PQ in the ratio lambda is to 1. Okay, let I take like this. P is here, P is 1 comma minus 4. S is here, which is 4 comma 0, and Q is 16 comma 16. Let this point S divide PQ in the ratio lambda is to 1. Okay, by using section formula I can find out. Using section formula, 4 comma 0 is equal to lambda into 16 plus 1 into 1. That is 16 lambda plus 1 divided by lambda plus 1. Comma, lambda into 16 plus 1 into minus 4. So 16 lambda minus 4 divided by lambda plus 1. Correct? Equate the y coordinate. I'll get the lambda value immediately. So if we equate the y coordinates here, 0 is equal to 16 lambda minus 4 divided by lambda plus 1. Ratio is equal to 0 if numerator is 0. So 16 lambda minus 4 is equal to 0. This gives lambda is equal to 4 by 16, which is 1 by 4. Correct? Lambda is 1 by 4. So ratio is lambda is to 1 you took. Correct? The ratio is lambda is to 1. The ratio is lambda is to 1. That is lambda is 1 by 4. That is 1 by 4 is to 1. 1 by 4 is to 1. Or I can write the ratio as 1 is to 4. Or I can write this ratio as 1 is to 4. So you compare with M is to N. This you compare with M is to N. M is 1 and N is 4. So M square plus N square. Finally they asked to find M square plus N square, which is 17. Option A. M is 1, N is 4. Correct? M square plus N square. 1 square plus 4 square. 1 plus 16, which is 17. A simple question. Okay? On the parametric relation between the endpoints of the focal chord. Please make a note. On to the next one. Question number 6. This is also a question asked this year only, 2025 JEE Main on 28th of January first shift. ABCD be a trapezium whose vertices lie on the parabola y square is equal to 4x. Sides AD and BC of the trapezium be parallel to y-axis and the diagonal AC is of length 25 by 4 and it passes through the point 1, 0. Find the area of ABCD. Okay. So y square is equal to 4x will represent first. Y square is equal to 4x. Y square is equal to 4x. The parabola is given. Y square is equal to 4x. Compare with y square is equal to 4ax. We get a is equal to 1. A is equal to 1 from the parabola. Okay. ABCD be a trapezium whose vertices lie on the parabola. AD and BC of the trapezium are parallel to the y-axis. The sides AD and BC, okay, are parallel to y-axis. And AC is of length 25 by 4. So I'll represent the trapezium like this. AD and BC. BC is here and AD is here. Okay. This is BC and this is AD, the sides which are parallel to y-axis, are parallel to the y-axis. Okay. The sides AD and BC are parallel to y-axis. Length of the diagonal AC is given and it is 25 by 4. AC is given as 25 by 4. AC is given as 25 by 4 and it passes through 1 comma 0 and AC is passing through 1 comma 0. 1 comma 0 is actually the focus, correct? Yes, the focus. Yes is 1 comma 0. That means AC is a focal chord. AC is passing through 1 comma 0. 1 comma 0 is the focus of the parabola because focus is a comma 0. A is 1. So a comma 0 is the focus of the parabola. Correct? 1 comma 0 is the focus of the parabola. Diagonal AC is passing through the focus. That means AC is the focal chord. AC is the focal chord, I can tell. AC is the focal chord. And length of the focal chord is given as 25 by 4. AC is the focal chord. Length of AC is given as 25 by 4. That means length of the focal chord is given. AC is a focal chord. This is A into T plus 1 by T the whole square. A into T plus 1 by T the whole square. A is 1, correct? So from this 25 by 4 is equal to 1 into T plus 1 by T the whole square. So if you expand it and simplify, taking square roots, I get T plus 1 by T is equal to plus or minus 5 by 2. I'll take T plus 1 by T as 5 by 2. Taking T plus 1 by T as 5 by 2, by inspection method, I can tell the value of T is 2 or half, correct? Or else you can get a quadratic equation. You can multiply the entire equation by 2t. If you multiply the entire equation by 2t, I'll get 2t square, correct? I multiply by 2t, so this becomes minus 5t plus 2 equal to 0. You can factorize this. 2t square minus 4t minus t plus 2 equal to 0, correct? From this 2t is common, t minus 2 minus 1 into t minus 2 is equal to 0. So t minus 2 is common, so I get t minus 2 into 2t minus 1 equal to 0, which gives t equal to half. T is equal to 2 or t is equal to half. If you take t is equal to 2, I can write the endpoints of the focal chord, correct? Taking t as 2. If you take t as 2, I can write one end of the focal chord as at square comma 2at. Taking t as 2, taking t is equal to 2, I'll write the coordinates of A, okay, the point A. A is how much? A is going to be at square comma 2at, no? At square comma 2at, correct? Which is A is 1, T is 2, 2 square 4, A is 1, T is 2, 2 into 1 into 2, 4. And C I can write. C is A by T square, comma, minus 2A by T. That is, C is A is 1, T is 2, 2 square is 4. A is 1 minus 2 into 1, T is 2, correct? 2 into A is 1, T is 2. So that is C is 1 by 4 comma minus 1, correct? C I am getting. A I got, C I got, correct? Now I can find out taking T as half. If you take T as half, I can write B and D, correct? Even BD is the diagonal which passes through the focus, even that becomes a focal chord, correct? BD I'll join. BD is another focal chord which is passing through the focus. So taking T as minus half, taking T as half, I took T as 2, no? Now I take T is equal to half. If you take T is equal to half, I can write the coordinates of B. B is how much? 80 square comma 280. A is 1 already. A is 1. T is half. Half square is 1 by 4. Correct? A is 1. 2 into 1, 2. T is half. 2 into 1 into half. That is 1. Correct? And D is going to be. D is what? The other end of the focal chord. A by T square comma minus 2A by T. A is 1. T is half. Half square is 1 by 4. 1 by 1 by 4 is 4. 2A. A is 1. So minus 2A. Which is minus 2 by half. Minus 2 by half. That is minus 4. So all the 4 vertices ABCD I got. I want to find area of this trapezium ABCD. Correct? So I can name this. I can mark this here. A is how much? A we got it as 4 comma 4. Correct? A is 4 comma 4. A is 4 comma 4. B is 1 by 4 comma 1. Correct? D is 4 comma minus 4. D is 4 comma minus 4. C is 1 by 4 comma minus 1. C is 1 by 4 comma minus 1. And B is 1 by 4 comma 1. Correct? B will mark here. B is 1 by 4 comma 1. Okay, I'll represent the trapezium ABCD like this. I'll add one page here. So ABCD trapezium looks like this. The trapezium ABCD. ABCD is a trapezium. No, okay. I'll mark like this. ADBC. ADBC. What are the vertices we got? The vertex A we got it as 4 comma 4. The vertex is 4 comma 4. Vertex D is 4 comma minus 4. This is 4 comma minus 4. Next, we got the vertex C as 1 by 4 comma minus 1. This is 1 by 4 comma minus 1. This is 1 by 4 comma 1. Correct? Area of this trapezium is half into sum of the parallel sides. Area of the trapezium ABCD is half into sum of the parallel sides. BC and AD are the parallel sides. For AD, you see that x coordinate is same. That's a vertical line, correct? So if you want to find the distance between the points A and D, subtract the y coordinates. 4 minus 4, 4 minus of minus 4, which is 8. So AD, sum of the parallel sides. AD plus BC, sum of the parallel sides into the perpendicular distance between those two sides. The perpendicular distance between these two. Correct? You can call this as EF. Half into AD is 8. BC. BC is how much? 1 plus 1, 2. Correct? Because x coordinate is same. Just subtract the y coordinates. What is EF? EF. Or else from the figure you can find out, yeah, EF, the perpendicular distance between the two parallel sides. To find out, F is the point on this, no, x coordinate will be same here. X coordinate will be same, 4 itself. Here also x coordinate is same, 1 by 4, comma. I need to find the perpendicular distance between these two, correct? I can find the perpendicular distance between these two as ABCD is a trapezium. Have they given the length? No. Length is given as 25 by 4. Using that, we got 1 passes through 1 comma 0. Correct, no? A is equal to 1. The parallel sides AD and BC. Need to find the perpendicular distance. And this point lies on x-axis, no? You can use that condition. This point lies on x-axis. This point lies on x-axis. So I can use that condition and get the coordinates here. This point is lying on x-axis, correct? So y coordinate is 0. Here also y coordinate is 0. So EF is how much? 4 minus 1 by 4. 4 minus 1 by 4 is 15 by 4. So how much you get? Half into 10 into 15 by 4. 2 ones are 2 5s are 5 into 15. 75 divided by 4. 75 by 4. Option A is the answer. Please make a note. Move on to the next one. Question number 7 we have. P is 4 comma 4 root 3 be a point on the parabola. Y square is equal to 4x. So this point lies on the parabola. Okay. PQ is the focal chord of the parabola. M and N are the foot of the perpendiculars drawn from the point P and Q respectively on the directrix of the parabola. Find the area of the quadrilateral PQMN. So we'll draw the rough sketch even for this. The parabola is there. Y square is equal to 4ax. Parabola y square is equal to 4ax. The point P 4 comma 4 root 3 is a point on the parabola. The point P 4 comma 4 root 3 is a point on the parabola. Therefore, it satisfies the equation. I can find the constant A now using that condition. So, put x equal to 4 and y is equal to 4 root 3 in y square is equal to 4x. Put x equal to 4 and y is equal to 4 root 3 in y square is equal to 4ax. Y is how much? 4 root 3. 4 root 3 square. 4 square 16. Root 3 square 3. It becomes 48. Is equal to 4 into A is, I have to find out. X is 4. So 4 into 4. 16 3s are 48. So value of A is 3 from this. Value of A is 3. The point P lies on the parabola, therefore it satisfies the equation. So I got the value of A as 3. So PQ is the focal chord of the parabola. Focus is 3 comma 0. Focus is 3 comma 0. PQ is the focal chord. S is 3 comma 0. S is focus. A comma 0. A is 3. So other end of the focal chord I can find out. We know P is 4 comma 4 root 3, which is 80 square comma 280. 80 square comma 280. A is how much? 3. 3t square. 3 into 2 is 6t. Compare. 3t square is equal to 4. 3t square is equal to 4 and 6t is equal to 4 root 3. So from this t is equal to 2 root 3 divided by 3, correct, or it is 2 by root 3. T is 2 by root 3. From this also we get t square is 4 by 3. So t is plus or minus 2 by root 3. I'll take t as 2 by root 3. Taking t as 2 by root 3, I can find q. Taking t as 2 by root 3, coordinates of q I can write. Q is a by t square, comma minus 2a by t, correct? Taking t as 2 by root 3, I can write the coordinates of q. Taking t as 2 by root 3, q is a by t square, comma minus 2a divided by t, which is a how much? A is 3, t is 2 by 3. 2 by 3 square is 4 by 3. Minus 2a. Minus 2a is 6. Minus 6 divided by t is 2 by root 3. That is how much? 3 3s are 9 by 4. This 2 1s are 2 3s are minus 3 root 3 I'll get. So point Q I got. Point Q is 9 by 4 comma minus 3 root 3. And the directrix is here. This is the directrix. X equal to minus 3. Further what they say, M and N are the foot of the perpendiculars drawn from the points P and Q on the directrix of the parabola. From the point P, the perpendicular is drawn to the directrix, and this is the foot of the directrix, M. Another perpendicular is drawn like this. This is N. So you want to find area of this trapezium PQMN. You have to find area of the quadrilateral PQMN, which happens to be the trapezium. Actually, these two sides are parallel. Okay, you can draw the figure a little bit neatly so that you can identify it. Okay, so area of PQMN I have to find out. So this is the perpendicular drawn from the point P to the directrix, and M are the foot of the perpendiculars on the directrix drawn from the points P and Q. So to find out the coordinates, I want to find area of this quadrilateral PQMN. Okay, what I'll do is I'll use the definition of the parabola to find PM and QN. So we know by definition of the parabola, the point P moves as that distance from the fixed point is equal to distance from the fixed line. PS is equal to PM, correct? So PM I can find out using PS. What is PS we can find out, correct? PS is applying the distance formula we can find out. Even QS I can find out, so that QS is same as QN. PS, by definition of the parabola, we have PS is equal to PM, correct? So PS we find out. What is PS? By using distance formula. PS is equal to, PS is root of x2 minus x1 the whole square, 4 minus 3 the whole square, 1 square 1, correct? 4 root 3 minus 0, 4 root 3 square, which is 48, root 49, which is 7. PS is same as PM. What about QS? QS is how much? You can find out QS here. QS is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. 3 minus 9 by 4. 3 is 12 by 4, correct? 12 by 4 minus 9 by 4. That is 3 by 4. 3 minus 9 by 4 the whole square plus 0 minus minus 3 root 3 the whole square. 0 plus 3 root 3 the whole square. 3 is 12 by 4, correct? No, 4 3 is 12. 12 by 4, 12 minus 9, 3 by 4. 3 by 4 square, that is 9 by 16. Root of 9 by 16 plus 27. LCM is 16. 27 into 16, how much? 27 into 16. 7 into 6, 42. 2 carry. 6 2 is 12 plus 4, 16. 27 into 1, 27. 2, 3, 4, 32. Correct? 2, 6 plus 7, 13. 432 I am getting. So root of 432 by 16. Can I simplify this? 16 2s are 32. 11 carry. 16. This is going to be 16 2s are 32. 11 carry. 16 7s are. So root 27, which is 3 root 3 I am getting. This is 3 root 3. I am getting SQ or QS is equal to 3 root 3, which is same as Qn by definition of the parabola. Okay, so we got Qn and Pm. Okay, now I need to find the perpendicular distance between these two, because this is nothing but the trapezium. These two are parallel to each other. Qn is parallel to Pm. So the perpendicular distance between these two is how much? This length is how much? This length is how much? We find out. This is the horizontal line, no? Horizontal line is y coordinate is same. So this will be 0, 4 root 3. This point here on y axis is 0, 4 root 3 on y axis. This point on y axis is going to be horizontal line. This is correct. So y coordinate remains the same. X coordinate is 0, and this will be y coordinate. All the points on this line has same y coordinate, which is minus 3 root 3. Correct. So this point is 0, minus 3 root 3. So this length is 4 root 3. This length is 3 root 3. 4 root 3 plus 3 root 3 is 7 root 3. So area of this trapezium PQMN is going to be area of the trapezium PQMN. Area of the trapezium PQMN is half into sum of the parallel sides into the perpendicular distance. Parallel sides are Qn and Pm. Correct? Qn and Pm. Qn plus Pm. Half into sum of the parallel sides into the perpendicular distance. Into the perpendicular distance, how much? Perpendicular distance is, that is 7 root 3 I am getting. Perpendicular distance. Half into Qn. How much is Qn? Qn is same as Qs, which is 3 root 3. Is it correct or not? 16 2s are 16 7s are. I think there is some mistake about SQ. I have a doubt in SQ whether the SQ is correct. 9 by 4 minus 3. Twenty-seven and 16 is 432. 432 plus 9, 441. Sorry, small mistake has happened here. This is 441. I didn't add this. Small mistake has happened here. Sorry. This is 432 plus 9. I didn't add it. That was a mistake. 432 plus 9, 441 it is. 441 by 16. And root of 441 is 21. Root 16 is 4. Okay, small mistake happened in calculations. So 21 by 4 this is. Okay, this is 21 by 4 here. This is 21 by 4 here also. Qn is 21 by 4. I didn't add 9 that time. This is 21 by 4. 432 plus 9 I didn't add. 432 plus 9 is 441. Root of 441 is 21. 21 root 16 is 4. 21 by 4. So Qn is 21 by 4. 21 by 4 plus 7. 21 by 4 plus 7 multiplied by the perpendicular distance is 7 root 3. Correct? 4 root 3 plus 3 root 3. This length is 4 root 3. This length is 3 root 3. 4 root 3 plus 3 root 3 is 7 root 3. Hence, we are getting it correctly now. So this is half into, here LCM is 4, 21 plus 7 4s are is 28, correct, into 7 root 3. 21 plus 28 is 49. 4 into 2 is 8 into 7 root 3. 49 into 7, that is 343. 343 root 3 divided by 8. 343 root 3 by 8 is option D. Please make a note. Use the concept that PS is equal to PM. Find PS by using distance formula. Find QS using distance formula. PS is same as PM by definition of parabola. Point P moves as that distance from the fixed point is equal to distance from the fixed line. PS is equal to PM. Okay. Similarly, QS is equal to QN. Okay. So answer is option D. Please make a note. Last session of this, we have question number 8. The parabola y square is equal to 12x is given. S is the focus. PQ is the focal chord of this such that SP into SQ is 147 by 4. C is a circle described taking PQ as a diameter. Equation of circle is given like this. Want to find beta minus alpha. So y square is equal to 12x is the parabola given to us. Y square is equal to 12x. Compare this with y square is equal to 4ax. Y square is equal to 4ax. 4a is equal to 12. So a is equal to 3. Value of a is 3. PQ is the focal chord of this parabola. Directrix is x is equal to minus 3. Okay. PQ is the focal chord of the parabola such that SP into SQ is 147 by 4. SP and SQ are called the segments of the focal chord, already I told. So PQ is the focal chord if you take, this is SPQ. SP and SQ are called as segments of the focal chord. Given SP into SQ is equal to 147 by 4. SP into SQ is 147 divided by 4. SP is what? A plus AT square. A plus AT square. And SQ is SP into SQ, sorry. SP into SQ is 147 by 4. SQ is A plus A by T square is equal to 147 divided by 4. A value is 3, you can substitute. 3 plus 3t square into 3 plus 3 by t square is equal to 147 divided by 4. You can take 3 common from this, also 3 common from this. 3 into 3, 9 comes outside. 9 into 1 plus t square into 1 plus 1 by t square is equal to 147 divided by 4. Correct? You can simplify this as 1 plus t square into here t square plus 1 by t square. You can cancel this. 3 3s are 3 into 49 is 147. So this 3 3s are, this will cancel 3 49s are, this 3 comes down, becomes 49 divided by 12. Correct? So that means t square plus 1 the whole square, t square plus 1 the whole square divided by t square is equal to 49 divided by 12. Correct? Or else I can write this as t plus 1 by t the whole square. T square, if you take it inside the bracket, becomes a t. Correct? So that will become, or else I can expand it directly. This is t power 4. T plus t is taken inside. T square is taken inside, becomes t. So it becomes t square plus 1 divided by t the whole square like this is equal to 49 by 12. correct? T square is taken inside the bracket, it becomes T. So now I can divide individually. T square by T is T plus 1 by T the whole square is equal to 49 by 12. I can expand this. For T plus 1 by T the whole square expansion T square plus 1 by T square plus 2. T into 1 by T cancels. So expanding this, I'll get T square plus 1 by T square plus 1 by T square plus 2 is equal to 49 by 12. T square plus 1 by T square is equal to 49 by 12 minus 2. Take LCM 12. 12 2s are 24. 49 minus 24 is 25. Cross multiply this and write all the terms to one side. What do you get from this? 12t square, correct? Multiply the entire equation by 12. 12t square. Also multiply by t square. 12t power 4 I'll get, correct? I'll get 12t power 4. Multiply the entire equation by 12t square. 12t power 4 multiplied by 12t square. This becomes minus 25t square plus 12 is equal to 0. Adding you should get minus 25. Multiplying you should get 144. I can factorize minus 16 minus 9 will do. Correct? This is 12t power 4 minus 16t square minus 9t square plus 12 is equal to 0. Can take a common there. From there 4t square is common. So what remains is 3t square minus 4. Here minus 3 common. 3t square minus 4 is equal to 0. 3t square minus 4 is common. Correct? 3t square minus 4 into 4t square minus 3 is equal to 0. This gives t square is equal to 4 by 3 or 3 by 4. Correct? T square is equal to 3 by 4 or 4 by 3. So T is plus or minus root 3 by 2 or T is plus or minus 2 by root 3. I'll take the value of T as minus root 3 by 2 so that I can find the equation of circle. They asked to find, I want to compare with this. Equation of circle is given like this, taking PQ as a diameter. So P and Q, which are the endpoints of the focal chord, are taken as the endpoints of the diameter and forming the circle equation like this. Because the circle equation is given in this form, I'll take T as minus root 3 by 2 and find out. Taking T as minus root 3 by 2, taking T as minus root 3 by 2, T is minus root 3 by 2. We can write the endpoints of the focal chord now. P is at square comma 280, Q is a by t square. P is at square comma 280 and Q is a by t square comma minus 2a by t. A is already 3, right? From the equation of the parabola, A is 3. Therefore, the point P is going to be A is 3, T square. T square is 3 by 4. 2A. 2 into A is 3 and T is minus root 3 by 2. So what is this? P is 9 by 4. 2 cancels minus 3 root 3. Q is A is 3 and T how much? T is root 3 minus root 3 by 2. So square of that is 3 by 4. Minus 2a. 2 into a is 3. T is minus root 3 by 2. 3 cancels, becomes 4. Minus will cancel. 2 goes up. 4 root 3 I'll get. 2 goes up. 1 root 3 cancels. 4 root 3. So taking this as endpoints of diameter, PQ is diameter. So diameter form of circle I can use. PQ is diameter of the circle. So using the endpoints of the diameter PQ, I can write the equation of circle. Equation of circle is x minus x1 into, this is x1 y1, x1 y1, this is x2 y2. X minus x1 into x minus x2 plus y minus y1, y minus y1, minus of minus, plus it becomes into y minus y2 is equal to 0. Equation of circle. So what you get is x into x square minus 9 by 4x minus 4x, minus into minus plus 4 cancels 9, correct, y square plus 3 root 3y minus 4 root 3y, plus into minus is minus, 3 into 4 is 12, root 3 into root 3 is 3, correct, 3 into 12, 36, equal to 0. So we can multiply the entire equation by 4 here, correct, as given, they multiplied by 64, the 64x square. So we can multiply the entire equation by 64, what do you get? 64x square plus 64y square. If you multiply by 64 here, 64 into 4 is 256. Here when you multiply by 64, 4 ones are 4 16s are, 16 into 9 is 144, correct, 144 and 256, that is 400x minus 400x, adding these two it becomes minus root 3 into 64 minus 64 root 3 y, correct, 9 minus 36, that is minus 27, minus 27 into 64, how much is 27 into 64? 27 into 4 is 108. 27 into 64. 27 into 4 is 108. 27 into 6 is 162. 8, 2, 7, 1728. So that will be 1728 minus 1728 equal to 0. Compare what is given, 64x square plus 64y square. What is given is 64x square plus 64y square minus alpha x minus 64 root 3y minus alpha x minus 64 root 3y, correct, is equal to beta, or minus beta equal to 0. This is given in the question. If we compare, alpha is 400, alpha is 400 and beta is 1728. Want to find beta minus alpha. Therefore, beta minus alpha, 1728 minus 400, which is 1328. So the correct answer is 1328. So all the questions we have solved completely of this session. The focusing on the concepts now of JE concepts. I discussed about the focal chord, length of the focal chord in terms of angle alpha, length of the focal chord in terms of the parameter t, and also the parametric relationship between the endpoints of the focal chord. Also about the segments of the focal chord, SP and SQ are the segments of the focal chord, and the harmonic mean of the segments of the focal chord is going to be the semilattice rectum, length of the semilattice rectum of the parabola, and also the focal chord, the shortest focal chord is the lattice rectum. All those things we discussed, and also I solved the questions related to this topic of JEE Main, previous year questions of this topic. Concept wise I've done it, okay, so that it is helpful to practice the concepts and problems. Okay, with this I conclude. Thank you.